Quarter 2, Module 2, Lesson 1, Newton's Law of Universal Gravitation. Gravitation is one of the four classes of interaction found in nature. It is the non-contact force that is responsible in making an apple fall, and it is responsible in keeping planets in their orbits. So, law of universal gravitation, the basic law that governs gravitational interactions. It states that every particle of matter in the universe attracts every other particle with a force that is directly proportional to the product of the masses of the particles and inversely proportional to the square of the distance between them. This is the equation for the law of universal gravitation. From the law of universal gravitation, we derive this equation. They derived, rather. Gravitational constant. G is the symbol for G stands for gravitational constant. It has a number value of 6.67428 times 10 raised to negative 11 Newton meter squared over kilogram squared, or rounded off 6.67 times 10 raised to negative 11 Newton times meter squared over kilogram squared. Here, if each of two masses exerts a force on the third, the total force on the third mass is the vector sum of the individual forces of the first two. Meaning, when we add the vector of the individual forces, the force 1 and force 2, it will result in the total force on the third mass. Okay, let's proceed with the problem. I have here this problem. Suppose the mass m sub 1 of one of the small spheres of a Cavendish valence is 0.0200 kilograms. 0.0200 kilogram. The mass m sub 2 of the nearest large sphere is 0.800 kilogram, and the center to center distance between them is 0.0800 meter. What is the gravitational force on each sphere due to the other? So, we need to find the given first. I'm used to this structure, given, solution, conclusion. So the gravitational constant that we tackled earlier, G is equal to 6.67 times 10 raised to negative 11 Newton times meter squared over kilogram squared. Then we can get here the mass sub 1, which is 0.02 kilogram. Then the mass sub 2, which is 0.800 kilogram. This one. Then the force and the center to the center distance between them is 0.0800 meters. Oh, sorry, it's not a force, it's the radius. The radius, the distance. Radius is equal to, because it's the distance, 0.0800 meter. The unit is meter. It's in meter. So we need to find the gravitational force. Fg is unknown. So let's proceed with the solution. Yes, let's use the formula F sub G is equal to G M sub 1 M sub 2 over R radius squared. Gravitational force is equal to gravitational constant is equal to the product of gravitational constant mass sub 1 and mass sub 2 over the squared of radius squared, R squared. So let's substitute them. The value for gravitational constant is 6.67 times 10 raised to negative 11 Newton times meter squared kilogram squared 0.0200 kilograms. 200 kilogram times 0.800 kilogram over 0.0800 meter squared. That is the radius. So the product of this and this and this will be 16 point, oh sorry, 0.10672 times 10 raised to negative 11 Newton meter squared over 0.0064 meter squared. Why Newton meter squared? Because kilogram times kilogram is kilogram squared. Then kilogram squared times meter squared per kilogram squared will be meter squared because it will be cancelled. Then 0.0800 meter times 0.0800 meter will be 0.0064 meter squared. Then this will result to 16.675 times 10 raised to negative 11 Newton. Cancel this one, and I cancel this one, Newton. Then, or we can simplify this, the scientific notation, into 1.67 times 10 raised to negative 10 Newton. Negative 10 because we move this point here. That's why we need to add 1 here. Negative 11 plus 1 is equal to negative 10. So the answer will be our gravitational force will be 1.67 times 10 raised to negative 10 Newton. The in the module, in the given example in the module, they use there this gravitational constant, the value of gravitational constant that is not rounded off. That is an exact value of the gravitational constant. But here I just use this rounded off value of gravitational constant because it's just convenient for me. Thank you. So our conclusion will be the gravitational force on each sphere due to the other is 1.67 times 10 raised to negative 10 Newton. That's all. Thank you.